Hi everyone, and welcome to this video walkthrough on how to install and configure SQL Server Failover Clustered instance. And it's interesting because I was looking at the statistics on some of my YouTube videos the other day, and what I found was interesting in the fact that this happens to be the most viewed video of all time. I mean, I've done live streams, I've done other videos, but this happens to be the most popular one, and I've had it on YouTube since 2015. In fact, I recorded this video in 2013, 1 year after SQL Server 2012 was released, and it is a part of my online course on Udemy, the SQL Server High Availability and Disaster Recovery Deep Dive. And interestingly as well, because I looked at the statistics on both Udemy and YouTube, this is the most viewed video. Interestingly, because again, SQL Server 2012 introduced availability groups, and Microsoft has been promoting availability groups since then, but there's still some use cases on how to use, rather install and configure failover clustered instances. This technology has been around for quite some time. It goes back to the days of Windows NT 4 and SQL Server 7. So there's still some use cases. People are still using it, right? So I decided to re-record an entire video walkthrough similar to this one, but I'm going to be using SQL Server 2022 with Windows Server 2022 Failover Cluster, right? But before we get onto the whole walkthrough, the one thing that I want to point out is twofold. Why don't I switch to my my architecture diagram? This is going to be the infrastructure that we're going to be building. You have a 2-node cluster, or we are going to be building a 2-node cluster with a storage area network or shared storage. Of course, you got your domain controller. And I wanted to set the expectations right. This is an architecture. We are going to assume that this is going to be a physical machine or physical implementation, meaning the machines that we're going to be using are physical machines. Notice there that the servers are now connected to the storage area network, right? I'm not going to be going through the process of connecting to your SAN, configuring storage area network, because you may have different storage vendor. You might have Hitachi or Dell EMC or HP or NetApp, and every vendor will have its own implementation, right? Maybe they're going to be using, or you're going to be using iSCSI or Fiber Channel or some form of hyperconverged storage. So I'm not going to spend a lot of time on the storage other than we'll present the storage to the failover cluster, right? Also, if you look at the TCP IP configuration here, you would see two network adapters. One is for the public network, the one that you're going to be using for connecting to the server using SQL Server Management Studio, remote desktop, your monitoring tool, your client applications. So it's also the network that you're going to be using to connect to your Active Directory, your DNS, and stuff like that. And the second network there is the heartbeat. Now, starting with Windows Server 2008, you don't actually need a secondary network adapter. You don't need a dedicated network adapter for failover cluster heartbeat communication, meaning the inter-node communication. Especially, of course, when you're dealing with virtual machines or public cloud infrastructures, because you don't really know what's happening underneath. You may have multiple network adapters on your Windows machine, but you don't know. Maybe the network adapter is already team nicked or nick-teamed. You got multiple network adapters functioning as one. Like I said, Windows Server 2008 onwards allowed you to build a failover cluster with just a single network adapter, right? However, here's the way I look at it. You're building a failover cluster for a reason. You want it to be highly available, fault tolerant, resilient, and able to handle any type of issues. So it begs to differ. Sometimes people are like, yeah, you can build a failover cluster with a single network adapter. Sure, but then it defeats the purpose of a highly available redundant system. And that's one reason why I have a dedicated network adapter for this. Again, the assumption there is you will be building a physical machine implementation. Like I said, there is a dedicated network for the heartbeat network adapter, right? It's not like, going through the same network as everything else. And of course, the public network adapter. So keep this in mind as we are going to be building the failover cluster and the SQL Server failover clustered instance as well, right? But I also wanted to point out the importance of planning. Before we even go through the walkthrough, the step-by-step process, it is very important that you really plan this entire thing. And I want to emphasize this because more often than not, people fall into this trap of, hey, it's easy. I'm going to go through the installation, use the wizard, click next, 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 and finish, and think that it's easy. Sure, the process is easy, but then here's a quote that I got from, I forgot who I got this quote from. It says, failing to plan is planning to fail. Having a plan set out spells the difference between being able to do this in less than 4 hours to taking weeks or even months with a back and forth communication or the lack of information, details on how you can implement the plan. That's why I would spend the first few minutes of this walkthrough just looking at what I use to start preparing for and planning for the implementation, right? So I have what I call the cluster preparation checklist, and this is like it's a simple Excel spreadsheet that I started using when I started building failover clusters more than almost 2 decades now. And it's simply a worksheet that I use to keep track of the details on how I can implement the failover cluster. So what's in the cluster preparation checklist? By the way, I'm going to provide a link to the resource where you can download the cluster preparation checklist right down below. The thing about this is it's simply an Excel spreadsheet or a Google worksheet, if you may, with different workbooks. Right? Let's have a look at the first workbook, and it has something to do with servers. The assumption here is you will be working in a large team where you have segregation of duties, and you happen to be DBA or the sysadmin taking care of SQL Server, and other team members are going to be responsible for stuff like this, the server. So for instance, you may want to grab this worksheet and send it to your either your server admin, your sysadmin, and they will provide the information for the specific worksheet, right? For instance, the host names, like if you look at the worksheet right over there, the host names of the machines, the version and the edition of the Windows Server operating system, the implementation, is it physical or virtual? Or although again, the assumption on the architecture diagram is that we are going to be using this for physical implementation. How much CPU, how much memory, what is its role? Plus, you see one of the entries in there, the last one, which is the Windows Server failover clusters cluster name object. We're going to start talking about Active Directory terminologies in the process because that is important as well. Right? So that's the first worksheet. You are going to be sending this to either your server guys, your sysadmins, so they can fill up this information. And then you have your network. The network is something that you would give to your network admins, hand it over to them for them to fill up the information about TCP IP settings, like the IP addresses, subnet masks, default gateway values, primary and secondary DNS. And then let them assign the IP addresses for these corresponding values. Now, this is also an opportunity for you to start looking at and evaluating whether or not the information that they provided is correct, right? For instance, let's have a look at the IP addresses there. Be curious. You might want to ask, hey, how come the heartbeat IP address for TDPRD 082 is .142 versus the one for TDPRD 081 is .81? Is that correct? Use this as an opportunity for you to start looking at evaluating this information and then communicate that with your network engineers or your whoever is providing the IP address, because we're humans, right? We could have like typos when providing this. The last thing you want is you're walking through the process, creating the failover cluster, and all of a sudden you get an error where, oh, there's a duplicate IP address. So again, this is an opportunity for you to start looking at this information once they filled up the spreadsheet. The third one is storage-related information. And this is specifically for failover clustered instances. Again, this is something that you would send out to your storage area network guys, your SAN admins, your storage admins. And this is specific to failover clustered instances. Because when you're dealing with availability groups, you don't necessarily need shared storage. So here, you're looking at the storage name, volume name, the path, the size, and what it's for. Like for instance, you have your SQL Server drives, drives H, I, and J for the purpose of your data log and backups. And then you have your witness disk. This is also an opportunity to talk to your storage administrators about whether these are thick or thin provisioned. Because storage admins, you may request for a 20 terabyte storage, but they're only going to give you 10, but it looks like a 20 terabyte volume, but it's thin provision, right? So have that conversation with them so that you can, you have that expectation of what happens when your database starts to grow, right? Then you have the cluster services. And of course, as a DBA, this is yours. This spreadsheet is for you, or this worksheet is for you to fill up. What will be the name, of course, of the service? In this case, it's a failover clustered instance. But correlate this with the information that you got from the server's worksheet and the network worksheet, because this is something that you will be using. For instance, the virtual server name has to coincide with the network name of the SQL Server failover clustered instance virtual network name, as well as the virtual IP address. And then service accounts. This one is something that you give to your Active Directory domain admins so that they can provide you with the corresponding service account, domain accounts for the SQL Server service account. Failover clustered instances still require domain accounts if you're implementing it on Windows. So you have to make sure that you have that information beforehand. And like I said, we're spending a lot of time on the planning phase because you want to make sure that you have everything, all the information with you as you go along with the installation and the configuration. Again, it's a difference between doing this in 4 hours versus doing it in 4 weeks, because of the back and forth between your server guys, your storage guys, your network guys, your infrastructure guys, and sometimes even the hardware people, right? Planning, it is very, very important, right? So here's the high-level overview of the steps, okay? You're configuring the disks. You're adding the failover clustering feature. You're running failover cluster validation wizard. We're creating Windows Server failover cluster. And because this is kind of like a long process, what I'm going to do is I'm going to break it down. So this first part will be from steps 1 to 5. The focus of this first video will be on building and configuring the Windows Server failover cluster, right? And then part 2 will be from steps 6 and 7, where you install and configure a SQL Server failover clustered instance on an already existing Windows Server failover cluster. And then part 3 will be to install your SQL Server updates. And I'm also going to be including how you can slipstream the process of including the updates, cumulative updates, as part of the installation process, right? Again, planning is key. I've given you the high-level overview of the steps. I've given you, the architecture diagram and the cluster preparation checklist. And if you're also somebody who's kind of like the idea of highlighting the process as you're moving along, or keeping track with checklists and taking notes, I've written a 3-part series article on MS SQL tips that goes through this process. The configuration is different, but the process remains the same. So you can go and look at those articles, print them out so you can follow along. All right, so let's start off with the first step, which is configuring the disks. Now, like I said, before I get into this, I'm not going to be configuring the disk specific to whichever storage vendor that you're going to be using. The assumption here is the servers have been configured, the storage is already attached to the servers, and all I'm going to do is to present the storage to the servers. All right, so why don't I jump into my my demo environment here. And by the way, this is I have 3 machines here. First is my Active Directory machine. Okay, the Active Directory machine, I'm logged in as, let me highlight that. This is my my Active Directory domain controller, and I'm logged in as the domain admin. And then I have another machine, which is the first server that I'm going to use for my Failover Cluster, Windows Failover Cluster. I'm logged in as this guy over here, security best practice. This is a this account is an ordinary domain user account. It does not have any privileges across the Active Directory domain or the network other than an ordinary domain user account. However, it is a local administrator on both of the servers that I'm going to use to build the Failover Cluster. Right? Again, security best practices, I'm already incorporating it here as well. And this account will also be used as the DBA. Right? So I'm going to be adding this account to the sysadmin role later on when I install and configure the SQL Server Failover Cluster instance. Right? That's that. If you look at the local permissions, it is a member of the local administrators group. Okay? Right there. Same thing. If I look at the other server in my Failover cluster, or the server that I'm going to add in my Failover cluster, I'm using this guy as well. Same permission. It is a member of the local administrators group. And there you go. Again, simply following security best practices. I want to make sure that we get that straight, because I've seen, frustrating enough, I've seen cases where people are doing this with domain admin privileges. Please, we want to make sure that we are exercising and implementing security best practices, right? So, first thing that we need to do is reconfigure the disk. So we log into the first server, and let's open up, well, if you look at Windows Explorer, right now we don't have anything. No disks, nothing other than the local disk, right? That's the only disk that we have. So let's open up the disk management console. And look at what we have. Notice that I have like 4 disks. 3 50 gig ones and 1 gig. Okay, both are offline. Like, again, this is where I'm going to be starting off of. These disks are shared disks, meaning whatever I do here on this server will automatically be reflected to the other server once I'm done with this. Right? So let's go ahead and bring the disks online. So right-click and then bring online. Right-click, online, and online. Okay. Then we'll initialize the disk. All disks have been initialized. And then we are going to be configuring the disk. So we'll create a new simple volume. Click next, next. This, anything that I'm going to be doing on the disks, on the networking, on the cluster, on the SQL Server Failover Cluster instance, they were all in the cluster preparation checklist. So I'm simply pulling the information from the cluster preparation checklist and using that to configure the Failover Cluster and SQL Server Failover Cluster instance. All right. So in this case, I'm going to be assigning drive letter H using SQL Server best practice of 64K file allocation unit size, and we'll name this SQL disk H. I'm going to do the same thing for the other disks. New simple volume, drive letter I, again 64K file allocation unit size, and rename the volume. Same thing with this. And by the way, this is an opportunity for you to really follow best practice. I've seen cases where people just take the default file allocation unit size, and in the process, when they're doing their best practice assessment of the entire server, they start to realize that the disks are not properly aligned. Then they would have to reformat. Again, this is one of the reasons I'm paying attention to this, because it is going to be a lot of work just to reformat everything, especially if you already have it in production. All right. We'll call this SQL disk J, making sure that it's a 64K file allocation unit size. Right. The last one, the last disk, is our witness disk. In previous versions of the Windows Server Failover Cluster, this was called disk quorum or quorum disk. But in this case, I am not going to assign a drive letter to this. So this is the option that I'm going to choose. Next, and then call it. In this case, I don't need 64K file allocation unit size for this because it's just a witness disk. Right? There's a reason why I am not going to assign a drive letter to this. For one, it's a witness disk. The cluster is going to use this as an extra vote to achieve quorum. And for one, if you have a drive letter, it will be visible inside Windows Explorer, and then people will start thinking, hey, I can use this for something. Right? I've seen cases where people would put in, because they have available space on that drive, they would put in database backups, files, move stuff around because they don't have a space, even though it's just 1 gig. People would put stuff in here not realizing that this is a witness disk. Right? And that's one reason I'm not going to put a drive letter in there, because I don't want people to mess around with this drive. In fact, if you start looking at Windows Explorer, now you see disk H, I, and J, but no witness disk in sight, which is what I want, right? Now, we've done this on TDPRD 081. Let's go ahead and do this and see what happens when we look at the other server. We open up a disk management console on the second server, and notice that the disks are there as well. Let me do a rescan. And the minute that I bring the disks online, it immediately picks up whatever it is that I did on the other server. So now you have SQL disk H, SQL disk I, and of course SQL disk J. The drive letters are different, of course, because they're different servers, but the volumes are there, which also tells me that I didn't properly rename this. So I'll go back later to the other server and rename it properly. But this is how you would know that your shared disks are actually working. When you do something on the disks on one server, it automatically gets reflected on the other server, right? So I will, of course, rename it properly. Again, best practice. The cluster doesn't really care. The only reason I care is because I'm going to be the one managing this SQL disk J. And I want this to show up properly. Later on, you'll see the value of renaming your resources, whether they're disks or network, renaming them accordingly later on as we go through the process. Also, let's do an all. Take a look at my TCP IP settings. I've got there we go. Information about my Active Directory domain. And then I've got my LAN network adapter with my IP address, subnet mask, default gateway. And then my heartbeat network with the corresponding IP address and subnet mask. Notice that this one does not have a default gateway. Right? It's empty, versus this one has a default gateway. And this is what will tell the failover cluster how to route traffic to which network adapter. Right? The one with the default gateway tells the failover cluster, hey, this network adapter can be used to route client application traffic. Again, Active Directory authentication, SQL Server Management Studio, remote desktop, client application, ODBC, anything, right? Versus the other one that does not have a default gateway. The cluster will assume that this is primarily just for heartbeat communication, and you'll see that later in the process. Let's have a look at this as well. Right, same thing. You have practically the same. And again, I'm not guessing. All of this is in the cluster preparation checklist. In fact, what I did was to have those available in my the jump box, so that I can simply use all the information in my cluster preparation checklist and put them in the configuration, the settings, and everything else. That way I don't have to jump back and forth between the cluster preparation checklist and the configuration. The goal is to make sure that you have everything that you've put, or the other teams, whatever it is that they put on the cluster preparation checklist, exactly what you have in your building of the failover cluster and the SQL Server failover cluster instance. All right. So next, we've configured the disks. Let's have a look at adding the failover clustering feature. Okay, and this one is simply enabling the SQL Server, not SQL Server, but the Windows Server failover cluster feature on both machines. Okay, so I'm going to open up my server manager here, and this, by the way, this has to be done on both servers, or all of the servers that you want to add to your failover cluster. All right, can't be on one or a few. It has to be on all. So we click on the Add Roles and Features. This one. And this would open up the dialog box, the Add Roles and Features wizard. Okay, click Next, Next, until you get to the Features dialog box. And this is where you check the failover clustering box. Okay. Now, doing this not only adds the role, or rather the failover clustering feature, it will also add the failover cluster management tools and the Windows PowerShell module for failover clustering. We do that. Click Next. And before I click Install, I'll check the Restart the Destination Server automatically, just in case it does require a reboot. as part of the process. We do this on this machine as well as on this machine. So we do the exact same thing, add roles and features wizard until we get to the features dialog box and enable failover clustering. Next, also click the box to restart just in case and install. Okay. Now bear in mind, this is something that you need to do prior to doing the rest of the steps. The feature has to be turned on first, and then you can proceed with the other steps that I've highlighted in the high-level overview, where you're running failover cluster validation wizard, you are building the failover cluster, do some configuration settings, but it has to be done first, right? So we'll wait until this thing finishes, and then we'll check both of the the servers. All right, so now that we're done with this, at least we know we can go ahead and proceed with the installation and configuration, so we'll get that. I want to go back to TDP-RD081 because this is the one that I want to use for building and configuring the failover cluster. The one thing that you can do to check if the failover clustering feature has been installed is by looking at the Tools menu and seeing Failover Cluster Manager in there, right? Like I said, it is important for you to have the failover clustering feature installed on all servers that you are going to add in the failover cluster before you even go ahead and do so. So let's open up Failover Clustering Manager in this case. This is going to be the tool that you'll be using moving forward. This is the tool that you are going to be using to do failover cluster validation, configuring a cluster, creating a cluster, managing resources, and so on and so forth. So become very, very, very familiar with this, right? So there are a couple of ways for you to validate. Let's have a look at the second part, which is running the failover cluster validation wizard. Okay. The beauty of the failover cluster validation wizard is the fact that this is kind of like a lifesaver. Prior to Windows Server 2008, you have to have all of your servers identical. I mean, top to bottom, hardware, software, firmware, everything, version of Windows, everything, right? And then you have to make sure that every component is in the hardware compatibility list according to Microsoft. This eliminates the need for that. Run the failover cluster validation wizard. If it passes the test, servers are fully supported to run failover clustering, right? That's simple. That's why, again, this is something that you have to do prior to creating the failover cluster and making sure that every test returns successful, right? So let's go ahead and run failover cluster validation wizard. Let me resize this. There are a couple of ways for you to run failover cluster validation. One is through this one, validate configuration. The other one is through here. And the other one is you can right click and then validate configuration. Okay? However you want to do it, there are options. When you get to the select servers or a cluster dialog box, you need to provide the host names of the servers that you want to add to your failover cluster. Add both. By the way, it may appear to be a simple adding the servers into the dialog box. And like I said, just because everything's easy doesn't mean it's you no longer have to understand what's going on. Two things. Number one, this is a test. Just adding the servers to this dialog box is a test whether or not, number one, failover clustering feature has been installed on the servers, and number two, DNS is working, right? Notice that I only typed host names, added the host names, and all of a sudden it filled in the fully qualified domain name of the server, right? If DNS is not working, you'll see an error here. And like I said, it's as simple as, I'll add the servers to the dialog box and that's it. No, there is something going on underneath that the Failover Cluster Validation Wizard is doing on your behalf. Okay. Click on Next. I could just run all tests recommended. This one over here, I could simply do this. But I want to show you the different tests that it is running underneath as we run the Failover Cluster Validation. Okay. This is a list of all the tests. You got your inventory where you have storage checks and then system checks. Then you have your network checks. And then you have your storage checks, disks, CSV settings, arbitration failover, and then system configuration. Okay. Notice that the storage spaces direct, right? This one isn't checked at all. And that's because the assumption here is you are going to be building a failover cluster for other purposes, not necessarily for storage spaces direct. And again, this is by default not checked. That's why when you do a run all tests recommended, it's actually not all tests. It's all the tests except storage spaces direct. Okay, keep that in mind because again, this is one of those things that you would see as we go through the validation and the report that will show up later. Okay, click Next. The amount of time it takes for this to run. By the way, I am also going to have this side by side. Okay, notice I have disk management in here. Got disk management and then failover cluster validation running in here. Notice that the disks rather have been taken offline. Okay, part of the test that the failover cluster validation wizard will do, and again I want to do this side by side, is to check for the disks. Right, this is what I was mentioning earlier. The disks are shared across the different servers that you want to add to your failover cluster. The cluster will check whether or not these disks are, number one, supported, whether or not they can be used for failover clustering, and number two, it passes all of these checks that you're seeing in the background. Part of that is taking the disks offline, arbitrating the disks, taking ownership, failing over, and then failing back, right? In fact, if we go and jump back to the other server, like 82 for instance, and look at disk management, it does the exact same thing. The disks are taken offline, right? Nothing. You wouldn't see all the configuration settings that we did earlier because now the cluster is doing its job of validating the tests as part of the failover cluster validation wizard. Okay. The amount of time it takes for this test to run depends on the number of disks that you have, the size of the disks, the number of network adapters, network configuration, the number of servers that you are adding into the mix. So the more servers, the more disks, the more resources, the longer it is going to take. So just we'll watch, we'll wait until the tests, all of the tests complete, because at this point it's just a disks being tested. There's still other stuff that needs to be tested, like the arbitration of the other resources, like the network, failing over, fail back, and stuff like that. So we'll wait until this is done before we can create our failover cluster. Alrighty, so the test completed, which is a little bit confusing, because when you start to look at this, summary says it's successful. Oops. Summary says it's successful. See that green icon? Yet the warning icon shows up in here. A couple of things here. One, the warning, well, the warning first and foremost, is a byproduct of you not checking storage spaces direct, because even if everything passed, you still see a warning in the icon because you didn't run storage spaces direct checks. Confusing, but it is what it is. But let's have a look at the report. Click on the View Report button. Right, you want to make sure that everything is really okay. Let's have a look at this. This will open up an MHD report, a browser-based report showing you the results of all the checks. So in my case, these three are okay. Inventory, network, and storage. I'm more concerned about the storage. Okay, so all of the storage checks returned successful. But I want to focus my attention on the system configuration checks because this one returns a warning. Let me go into that. First off, I want to look at the first item here. Validate all drivers signed. That's the first warning. And then the second warning has something to do with the validate software update levels. Okay, so let's take a look at the first one. Validate all drivers signed. Here it tells me about Microsoft Remote Display Adapter. Both of them, actually. Okay, I'm not really concerned about this because, for one, this is going to be a failover cluster server. Typically, I wouldn't be logging into the server like this, with remote desktop or even with KVM. What I would do is I will install remote server administrative tools on my Windows workstation, Windows 10, Windows 11, and then manage the failover cluster using failover cluster management console or the PowerShell modules from my remote workstation. So I'm not really concerned about this, and besides, you're not going to be running very expensive GPUs on your failover cluster servers. So I'm not really concerned about this. The second one I can also ignore, not because I don't really care, but because when you look at the software update levels, it tells me that there was an error in retrieving the Q of E for both of the servers. Okay, and this is typically a side effect of the servers not being connected to the internet. And as the failover cluster validation wizard is running, it's checking whether or not the server is properly updated. In my case, I'm using an RTM version of Windows Server 2022. Typically, I would update the servers first before I even add them to Active Directory. But in this case, I was just working with the RTM version of Windows Server 2022. I can go ahead and ignore this. It's just a warning anyway, but again, a good best practice is to make sure that the patches are updated, your Windows is updated with all the patches installed before we even do this. Okay, those are the only things that my failover cluster validation report tells me, which I want to keep this open because we are about to install, or rather create, our Windows Server failover cluster, right? Now, before we do the creation, go back to your cluster preparation checklist. You have everything in there to configure the failover cluster, create the failover cluster, and configure the failover cluster as well. So why don't we jump into the text file, right? It's just a text file. This one has the IP addresses for the virtual computer name or the cluster name object. It's an Active Directory term for the computer account of the failover cluster, and then the virtual computer object for the SQL Server failover cluster instance. IP addresses and the names are there. Okay, I grabbed this from the cluster preparation checklist, plugged it in here so that, again, I don't go back and forth between the slide deck and this, but it's there, right? I'm not guessing. I took this from the cluster preparation checklist, right? So let's go ahead and create the Windows Server 2022 failover cluster. Okay. Now, similar to running the Failover Cluster validation wizard, you can do this on any node or any server that you want to add to your Failover Cluster, right? It's as simple as simply checking this box, right? Create the Failover Cluster or create the cluster using the validated nodes, check that box, and then click Finish. Simple as that. But sometimes people forget, okay? They close this and then they forget, right? What you can do is you can right-click here and then create the cluster. That's one option. Okay, that's one option. This is another option, and another option, just in case you forget that that dialog box has a built-in mechanism for you to create a failover cluster. Okay, let's go ahead and create the cluster. Create the cluster. Or create the cluster, however. And then from here on, we are going to provide the names, just like what we did with the Failover Cluster Validation Wizard. Let's close this. Close. Yep, seems like it's stuck somewhere. So let me close this and task and open up another instance of the Microsoft Management Console for failover clustering. Right, and oops, go ahead and create the cluster. Create the cluster. So we'll provide the names. Click Next. We are going to provide a cluster name. Like I said, it's already there. TD-PRD CLS 086. With an IP address of 197.215.0.86. Click Next. And then there's an option here that says add eligible storage to the cluster. Now, if this, because we're using this specific cluster for failover clustered instances, make sure that you're checking that box. If you are building the failover cluster for availability groups, please do not check that box. I've seen cases where people would add node to a failover cluster, create a failover cluster, and then checking this box, and their intent was to build a cluster for availability groups, and all of a sudden their SQL Server databases go offline. I've worked on a case a couple of years ago where one sysadmin added a node, forgot to uncheck this box, and their AG was offline for 16 hours. Just because this. Again, word of caution, make sure that you do not check this box if you're building an availability group, but for failover clustered instances, go ahead. Okay? We'll do that next. And I don't know if you noticed, it automatically threw up an error. Interesting, right? It automatically threw up an error. It says an error occurred while creating the cluster. We haven't even started, and I get an error. Yep, I do get an error. Like, let's open up the report and see exactly what the error is. And I was kind of expecting this. The error has something to do, oops, not this one. The error has something to do with permissions. Access is denied. And this is kind of frustrating because when you go back and look at the Failover Cluster Validation Wizard reports, I only saw issues with the drivers and the QFEs for software updates, right? But here it's telling me that it did encounter some issues related to Active Directory, right? Why is that? Well, let's go back to the Failover Cluster Validation Report. And this is what is something that I am still frustrated at this point. This tells me that the Active Directory stuff, anything that is related to Active Directory is okay. The report tells me so, and everything's fine. Fun fact, this was working up until Windows Server 2016. Prior to Windows Server 2016, when your domain account does not have permissions to create Active Directory objects, it will throw an error, not an error, but a warning telling you you don't have permissions. So you don't go ahead and build a cluster and then get surprised when something like that happens. We've raised this issue with Microsoft. I don't know why after several versions, and now we're on Windows Server 2022, it's still not fixed. I don't know if it's a bug or a feature, but here's what I started to do after Windows Server, starting with Windows Server 2016. Assume that my account does not have permissions in Active Directory to create computer objects so that I can go ahead and request for those permissions, okay? And that's one of the reasons why this is kind of like, it's really annoying because it was working in Windows 2012. Yeah, up to Windows 2012 R2. So here's what we are going to do. We are going to grant permissions in Active Directory, right? And there are specific permissions for creating failover clusters in Active Directory. For one, there is a Microsoft document. It used to be a KB article. There is a Microsoft documentation that walks you through what permissions are required. In this case, I've highlighted it, to create computer objects and read all properties permissions in Active Directory. This is the minimum requirement, which means the account that you are using, in my case, the domain account that I'm using to build a failover cluster, needs to have this permissions. Now you can go ahead and request for that permission from your Active Directory guys. Say, hey, I'm building a failover cluster. Please grant my domain account to create computer objects in Active Directory. Okay, and you can give them a link to the Microsoft documentation, right? Now, in some cases, there are restrictive environments where domain admins don't even want to give you those types of permissions. And again, highly regulated, requires meeting security compliance requirements. They might not give you those permissions. So what you do in this case is to ask them to grant you, or not grant, but to pre-stage the computer account. And what this does is it will create, I mean, you can send them a link to this Microsoft documentation, is they will create the cluster name object in Active Directory beforehand and then disable it. So that when you start creating it, you're no longer creating the cluster name object in Active Directory, you're just re-enabling it. Again, that's the Microsoft documentation for that. And this is also one of those things that you can prevent from happening. And the reason why I allowed this to happen is because, again, it's one of those things where the failover cluster validation wizard told you, well, it's okay, right? But then you went ahead and then it isn't okay. Plan ahead. Request your permissions. Request for those permissions from your Active Directory admins, or pre-stage those permissions before you even create the failover cluster, right? I know I've created the cluster preparation checklist with the corresponding worksheets, rather, information, but I did not include this because I want you to see that this is something that would come up regardless of what the failover cluster validation wizard says. So again, I automatically assume now, starting with Windows Server 2016 and higher, that I don't have permissions. I will ask for those permissions. So why don't we go ahead, right? Why don't we go ahead and get into our domain controller. I'm going to jump into the domain controller. And as I mentioned, the account that I'm using here is one of a domain admin account, right? It has domain administrator privileges, unlike the one that I was using when I was building the failover cluster, right? So I am, well, pretty obvious, I'm the domain administrator. Okay. There is the computer's OU. Okay. In Active Directory terms, this is called an OU, or an organizational unit. Okay. The cluster will be created inside the computer's OU, or wherever your Active Directory folks want to do that. So what you do is you request for permissions to create computer objects in this OU, this one. Okay. So as an Active Directory domain admin, I will grant that domain account permissions. To do that, click on View, and make sure that the Advanced Features is selected. Okay. Right now, oh, let me backtrack a bit because that was pretty fast. If you don't select that option, it's just a handful of OUs within the existing Active Directory domain. But when you do enable advanced features, you see more. Okay. Oh, by the way, this is a great opportunity for you to see that the user that I'm using to create the failover cluster is simply an ordinary domain user, right? No special permissions, nothing. It's an ordinary domain user. Again, security best practice. Anyway, so let's get back here. Computers, right-click this OU and click Properties. Then click on the Security tab. Okay, it's just like granting ACLs and NTFS permissions to a folder, but in this case, it's an organizational unit. Okay, click on the Advanced button, and this will give you additional permissions other than what you can see here. Okay, click the Add button, and then click Select a Principal. We are going to be granting that account the Create Computer Objects permission. Okay, so that's going to be that account. Click OK. Click OK. And then when you scroll down, you should see the Create Computer Objects. This right here. Okay. Make sure that you grant that account Create Computer Objects. Click, then OK. Apply, then OK. So now you have this domain account with special permissions. Okay, that's what you need. This domain account with special permissions, and that is to create computer objects. Again, make sure that you have you request that permission from your Active Directory guys. Do that before you even create the failover cluster. Just like what you saw, even though failover cluster validation wizard reported everything to be okay, it actually didn't. Okay, so keep that in mind, right? So let's get back to this and jump back to that server. Now, because this server has encountered some issues with the errors and whatnot, why don't I use the other server to build the failover cluster, right? It's the same thing. I mean, you could use the failover cluster management console on any server now that it's installed on all of the servers. So why don't we do that? We'll go ahead and create the failover cluster. We'll add the servers in the select servers dialog box. Provide a cluster name object. Okay. Click next. And then next. And now it's done. See the difference between this and the other machine where we were working on an assumption that we have the permissions, where it immediately caused an error, threw an error, and then reverted back, and then gave you the report that says you don't have permissions here. You already have that permission. So all we have to do here is wait. And there you go. The cluster has been completed, created, and now you have a failover cluster, right? But before we get into this, before we start looking at the failover cluster, I want to go back and see what it did in Active Directory. Okay, let me jump back to my Active Directory computer, do a quick refresh. Okay, you have a new entry in Active Directory, and by the way, I've got my DNS management console in here. I have a new entry in here, which corresponds to this entry in a DNS. Okay. In Active Directory terms, this is called cluster name object. Cluster name object. Okay. This is the virtual computer name, and if you can see the description over here, it says it is the Failover Cluster Virtual Network Name Account. It's a computer account for the failover cluster. IP address has been assigned. Okay, so part of the process, and that's one of the reasons why it is very important for you to see the interaction between Active Directory, DNS, and the failover cluster. You created a failover cluster, provided the computer name. It talked to Active Directory, since you have the permissions to create a failover cluster, created a computer account in the same OU, or organizational unit, as the nodes, and then once it successfully did that, created a corresponding DNS entry with the virtual IP address. Okay, that's the interaction between the failover cluster and the DNS in Active Directory, right? That's also one of the reasons why I said this is a team sport. You got to understand what's going on under the cover so you can communicate that with your Active Directory guys and or your DNS guys if they're on different teams. Okay. So there goes your cluster name object. Now that we have all of this, we can go ahead and rename the clustered resources. Now, this is something, you don't have to actually do this, okay? The only reason I like doing this is because, for one, we're humans. And when you're troubleshooting stuff, when you're trying to fix an issue, trying to solve a problem, you want it quick, you want it fast, and if it's not properly configured, there's a couple of different things that could confuse you, taking the troubleshooting process and issue resolution a lot longer, right? That's one of the reasons why I'm always looking for how I can configure those resources for my advantage, not for the cluster's advantage. Okay, so let's jump back into one of those servers. Like I said, you could use either of those nodes now I'll use TDPRD082 since I already have it. Let's take a look at what we have here. Expand. Well, let's look at what the cluster is telling us. You have the cluster and the current host server is TDPRD081. And the witness type is cluster disk 4. And if you expand this, tells me other things as well. You got your cluster name object and the virtual IP address and your witness disk. Unfortunately, it's called cluster disk 4. Well, what is cluster disk 4? I don't know, and that's one of the reasons why you really need to properly name your resources. Let's first start with storage. Okay, expand storage, and then select the disks object. Click on that, and this will tell you all the different disks that I have. Unfortunately, they're very intuitive. It tells you cluster disk 1, 2, 3, and 4. It doesn't tell me much. Okay, so what we'll do is we'll start renaming all of these resources. Okay, so this is the first one. We know for a fact that this is the witness disk. I'm not going to change the drive letter. Okay. However, I am going to rename. Okay, so right-click on the disk, properties. I just want to be consistent with what I have in my Windows Explorer. Excuse me. This one is SQL disk H. H or H. Yeah, there's something wrong with my keyboard. Anyway, this is SQL disk J. And this one is SQL disk I. Like I said, the cluster does not need this, but I do. When I look at this, I know, oh, this is, well, I can look at the disk numbers, but it doesn't make any sense at all, right? But here I can see that this is SQL disk H, this SQL disk I, and SQL disk J. Why don't I do this? Nah, I'll keep it as it is. And it also tells me at the moment that all of these disks are owned by TDPRD081. Okay, so we're simply reconfiguring all of the storage in this case and the networking. So why don't we jump into our networks? Okay, and configure this. Now at the moment, all I have are these. Oops. These two. It doesn't really tell me anything other than the fact that this is cluster network 1 and cluster network 2. When you click on this, or when you select this, oops, and expand, under network connections, it tells me, let me resize this. This is my LAN, network adapter. It tells me the IP address for this. So what I can do is right-click properties and rename this to something. Okay? And because I have the default gateway, by default, this box is checked. It's also one of the reasons why you could see cluster U says cluster in client. Okay. Click apply, click OK. We'll look at the second one. And this one pertains to my Heartbeat network. And by the way, because I've specifically renamed my resources, my disks, it's easy for me to identify these. I can rename this as well. And notice that this one does not have the checkbox selected by default. So I see here it says cluster only. This is a side effect of this network adapter not having a default gateway. Apply and OK. Okay, but notice both of these, both of these have cluster, which means the cluster can use any cluster network adapter for heartbeat. And that's one of the reasons, again, why most people would say you don't really need additional network adapter for heartbeats communication because the cluster will use all of the available network adapter, which also highlights the fact that if you only have one, then if that network adapter dies, hardware failure, firmware issues, driver issues, then your cluster can no longer communicate with other nodes in the network. And that's why it's important to have multiple network adapters, even if you are configuring multiple network adapters in a NIC-teamed fashion. Be sure that you do have more than one for redundancy, resiliency, fault tolerance, because again, your goal is high availability, right? So we have a working failover cluster. And if you go back to this, now it's starting to make a bit more sense now. This is my cluster name. I got my witness type is witness. And this is my cluster core resources with my virtual computer object or cluster name object, Active Directory terms, and my virtual IP address. Okay, you now have a working failover cluster. That's important. Okay, it is also important for you to start doing stuff like simple failover tests, and it could be as simple as running a simple ping test and then rebooting a machine. It could be as extreme as unplugging network adapters and see if they're working fine. It could be as drastic as unseating CPUs or RAM modules. It's interesting because, again, in the days of physical machines where you have access to data centers and you want to do a failover test just to make sure that the hardware is really the way it is configured and your hardware vendor is really living up to what they're promising on their marketing collateral. I love the idea of pulling out power supplies and network cables, but nowadays, everything's remote. You're accessing everything just like what I'm doing here. Everything is getting accessed using either a KVM, a remote desktop, public cloud infrastructure. So there's no fun in that. So if you want to really test your hardware, you got to be physically in a data center and then making sure that you have all the tests that you could do. I mean, simple tests. The idea behind this is now that you have a working failover cluster, you want to make sure that it's rock solid, it's stable, reliable, highly available, fault tolerant, resilient, what have you, before you even install the SQL Server Failover Cluster instance. So I'm going to stop right here and pause right here. Watch everything from start to finish. Take notes as much as you can. Go back to that portion where you saw me encountering errors and issues, because you need to include that as part of your cluster preparation checklist. Oh, I need permissions to create Active Directory objects and whatnot, right? In part 2, we are going to be installing SQL Server Failover Clustered instance on this failover cluster, and then adding a node to an existing failover clustered instance. And then on part 3, we're going to be installing updates like cumulative updates, service packs, although service packs stopped at SQL Server 2016. But I'm going to walk you through that process, right? So again, watch the entire recording, practice, build your own environment, and make sure that everything's rock solid before you even install a SQL Server Failover Cluster instance. All right?